Yeah. Yeah. All right. So let's get started then.
Okay. Well, thanks for inviting us. Ideally, this would have been an interactive session, but we're a long way away. And just to preempt any common misconception about Australia, we're not Austria. We are, in fact, a long, long way away. And this is working incredibly well, this the remote session we've got going here. But in any event, we both have beer, but we have crocodiles and Austria doesn't. I guess the connection must be bad because I can't hear enormous amounts of laughter. Thank you. Okay, so what we want to talk about this morning is an effort that we've had going on for about 5 years now in addressing the same problems that this entire workshop is about, and I've just stolen this description of the problem of training for bioinformatics from the workshop description on the web here, and I'll just quickly go through this and talk about how this matches against our efforts in developing a platform for training. So, bioinformatics analysis typically involves a large number of software, tools and reference data, and if you need to start from scratch, from zero, that's a very, very long task, and probably most people who attend our training courses couldn't do it. The problem is aggravated in a course setting, absolutely, and we need everyone to have everything work, basically. You need to guarantee that if people follow the instructions, that what you're doing is going to work. And that requires a whole bunch of things, not just the right tools, but also the back-end compute and reference data and resources to make that happen. And this last one is actually a really hard one to achieve. It's something that we've been working towards, which is to provide an access to an identical setup after the course. The talk after ours is from Annette and Jericho, also from Australia, and they're going to talk about a slightly different approach to providing a training platform that is a little more focused on a managed environment than ours, and I think both the approaches are complementary. So just briefly, in order to get bioinformatics, or more, we do mostly genomics. We don't do a lot of proteomics and transcript and metabolomics, mostly genomics. What you actually need, everyone here knows, you need some sort of Linux server or cluster, depending on how big the jobs are. Needs to be configurable, needs to have many analysis tools, needs large amounts of storage generally. Not so much for training, but if you want to do anything afterwards. Ideally, you'd have a different suites of analysis platforms, and I've just listed 3 examples here: a workflow platform, depending on your audience, some sort of statistical interactive platform, and a computational interactive platform, analysis platform, and access to reference data, again, depending on what you're doing. Training is actually, in some ways, even more demanding than just a general bioinformatics environment. In our experience, at least, it's transient. That is, it doesn't last very long, but when you have it going on, it can be extremely demanding. It's bursty. And if you get 30 students looking to do an alignment or an assembly task at once, that can be extremely demanding on your back end. And if that's just for a half-a-day workshop, that's something you need to think about in designing your environment. Typically, training materials are developed centrally and then distributed outwards and delivered in a distributed environment at different locales, and therefore you need to somehow provide access to those different locales for the appropriate environment. And again, this last one is really important. I think that's in any tutorial we've ever given, there's a range of expertise of people going in, and accessibility is the key. You often end up settling on the lowest common denominator for access, and I'll talk about what that is for us, but basically that normally means a web browser is the only thing you can really rely on. And all the training is running on a fairly complex, ideally online and highly controlled tool and data environment. So the project that we've had running for about 4 or 5 years now, trying to provide such an environment, is called the Genomics Virtual Lab. It's been a government-funded project here in Australia. It's driven by a number of the characteristics that I just discussed when we broke down the problem of providing a training environment. That is, it's designed to be highly accessible, and that is by building it on the cloud and making it available through the web, to be scalable by building it on the cloud, to be flexible through providing multiple services and providing the ability for the user to actually manage their environment. That's important. And you often sacrifice accessibility to for flexibility. Reproducible, in that it's actually launchable by either the trainer or the user, and it should be able to run on any cloud, and that's what we're aiming for with the Genomics Virtual Laboratory. And of course useful by providing lots of tools in a working format with reference data and tutorial material that works with that environment. So the Genomics Virtual Laboratory is actually described in a paper that we had published last year, but it's also a website. The website follows the paradigm of Galaxy. Many of you might recognise the use, get, learn paradigm, and in fact we started out essentially building a Galaxy deployment platform for the web, for the cloud I should say. But this paradigm works quite well, I think, for providing a platform for both training and for practice. The use some managed services, get, that means build your own, and learn is the materials that can be used on either of those first two. We're going to talk mainly today, and I'm going to hand over to Simon shortly, about the get function here. That is how you build, or how students build, or how you build for students reproducible, highly configured, highly accessible and usable environments for doing bioinformatics. But very briefly, the process, because it's a cloud-based platform, is that we have a fairly simple launch page where you put in cloud credentials and specify a little bit of information about what you need, including whether it should contain Galaxy and what reference genomes you would like made available. And you press go, and after some minutes you end up with a cloud-based server or small cluster which provides a whole suite of services, and those services are listed here. We have Galaxy and a desktop, a secure shell connection, a Jupyter Hub and an RStudio. These are all web accessible, so the desktop is web accessible as well. And importantly, the tools that are available to one of the services, workflow services like Galaxy, are also available on the command line and available to RStudio and the Jupyter Hub. You can manage the back end using a fairly sophisticated console, and this console is the Cloudman console, which has been developed in conjunction with the Galaxy team. But basically, these three little nodes here are the worker nodes. It's got a Slurm cluster underneath it, and you can sort of scale that up or down as you need to, and you can configure other parts of the overall platform as well. And with that, I'll hand over to Simon, who will talk in a little more detail about how the GVL works.
Okay, thanks, Andrew. So today I'm going to talk about how to use the GVL for training, how to start it up, and how to give your students access to it, and what's happening in the back end when you do all that thing. So I'll start off by saying, let's say you're going to run a workshop or a bioinformatics training course for a bunch of students, and you want some infrastructure for the course, and you want each student to be able to use the same resources regardless of their own personal circumstances or what device they've brought along to your course, whether it be a Windows laptop or a Linux laptop or a MacBook or even an iPad. So, and it's not just for this course, it may be for other ones that you want to do in the future as well. So the thing we can do is we can launch some Genomics Virtual Laboratories in the cloud. So I'm going to talk about how you do that and what's going to happen when you do. Thanks. Okay. Oops, you already changed it. Okay, so you can use a web-based GUI to launch the cloud machines. You can do this yourself, but we found it much better if we get the students to do it. And I'll explain the reasons why that is a bit later on. But all you need to do is give this web page your cloud credentials. You choose the size of the instance you'd like to start, number of cores, how much RAM, etc. Look at the tool set, select the reference data, and then press go, basically. Or you can launch multiple instances at once using a command line tool. But deciding whether to use one large machine or lots of small machines is generally up to the trainer, and it depends on what you're trying to teach and what you're trying to get out of the course. A lot of the times I'll use lots of small instances and give the students access to one each. Occasionally I'll just do one large one and get everyone to log into that. But regardless, this command line launch, all you need to do once again is just follow the prompts. You give it your access keys, what size instance you'd like, which image you'd like it to use, the number of instances you want to start, between 10 or 40 or 50 even, and then you give it some user data. And the user data is a YAML file which contains which set of reference data and which toolset you'd like to add to all the instances that you're starting up in the cloud. So what happens when you press go? So firstly, the GVL launcher and the Cloudman asks the cloud of your choice to provision an instance for you. And then Cloudman starts up the GVL-based Ubuntu on it. Once that happens, it attaches a volume which may have user data on it, but it's generally a large disk. It then pulls down and mounts a file system containing pre-installed bioinformatics tools and a Galaxy visualization platform. And the really important part here is that all the tools that are available in Galaxy are also available on the command line. So you've got two different methods of access for the same pre-installed, ready-to-go Galaxy tools that everybody has the same version of. And then it mounts a second volume with pre-indexed reference genomes and a whole bunch of other reference data. So not just raw sequence data, say the human genome or the mouse genome or whatever you need, but it also includes indices for various tools, so like the BWA-MEM index for the human genome. And that's all pre-calculated and sitting on this reference volume that just gets attached to your instance in the cloud. And that's really important because it can take quite a long time to index some of these larger eukaryotic genomes for all the different tools that you might want to use in your tutorial. Then it adds alternative interfaces for interactive analysis, say on Jupyter Hub. It talks about, it also adds RStudio for statistical analyses, and then it makes them all available as web interfaces, so all as web services. And everything is handily accessible from that dashboard that Andrew showed you a little bit before. Cloudman, the whole time this is happening, Cloudman is the bit that's doing all this work. It's pulling in all the bits, making sure they're all connected correctly, but it remains available at the end of it to manage all these services and volumes. But you can also dynamically use it to add or remove compute nodes to the original instance. So you started up this original instance, but you can dynamically add and remove more bits of compute to turn this little instance into a cluster. And the original node then becomes the head node, and all of the others become worker nodes. So this allows this instance to expand to meet any of its future needs. If you can wish, you can use the same instance to run a workshop for 2 people, and then next week just fire up some worker nodes and you've got the same instance running the same workshop for 30 people. So now the instance is fired up, the whole process usually takes somewhere between 2 and 10 minutes, and it's customizable and modular. So different combinations of tool sets and reference data can be used on any instance via the launch page. All of the interfaces to the machine are accessible from a single IP address via a web browser. Therefore, students don't need to have VM software or certain versions of Linux or Mac or Windows or even any local tool installs. Just an internet connection and a compatible web browser, unless they're compatible anything other than Internet Explorer. So yeah, I've even had a few students come up to some of my training courses, and they've walked in and said, "Oh, do we need a laptop?" And I said, "Oh, yes, that would be handy if you're going to participate." And they said, "Oh, I've got my iPad. Can I do it on that?" And I went, "Of course, you can. If as long as it's got Safari on it, you can work." It's been difficult for them to look at the screen, but they can actually follow the course. So the data that you require for your workshop can be stored anywhere you like, as long as it's internet accessible. So it can be made available to the students via, say, Genome Space, which is this thing here. It's a tool produced by the Broad Institute in America as a data broker, where it'll connect to storage in the cloud somewhere, and then allow you to move that data between the storage and any of the tools that you see along the top toolbar there. So Galaxy or IGV or the UCSC table browser, for example. Or you can just store it in your cloud's version of the S3 bucket system, or you can even just copy the data onto each instance via an automated script, which is usually written in Ansible. Oh, what have I done here? Does anyone know how I can get there? Thanks. We go. Thank you. Okay. So far, the GVL has been used for all sorts of bioinformatics training. Our instructors have used it for command line bioinformatics courses, for HPC training. Because the GVL is a cluster in the cloud, it contains Slurm, which is a cluster scheduler, so you can teach HPC courses on it as well. We've used it for Galaxy-based bioinformatics training, and we've even taught software and data carpentry courses using the Genomics Virtual Laboratory. So the good thing about the GVL is that it's completely customizable. Different tool sets can be easily built for it, and I've done this in the past using a thing called Ansible. And Ansible is just a computer controlled scripting language. And so as an example, I've built a customized tool set and customized reference data set for the GVL for doing microbial genomics. And basically it's just a set of YAML files that are all connected, with basically listing which tools I want to install and how to install. And at the end of it, I've got a customized version of Galaxy, a customized tool list for the command line, and it also includes lots of visualization software yeah. So all of these different tool sets and references we would call a flavor of the GVL. And all of these flavors are all selectable from the original launch GUI that we talked about. And if anyone's interested in even learning how to build or add to the GVL or customize it for your own purposes, everything's contained at GitHub in the GVL project. It's all based on Ansible. So there's two different things you need to do. You take a vanilla Ubuntu, you run the first Ansible script on it, and it will turn it into the GVL Ubuntu. And then you run the second GVL script, which you can customize in any way you like, and it will build, install the tools, etc., and then make an object of those tools and put them into some cloud storage somewhere that the launcher can get to, and then they all get combined when you go to launch an instance.
Okay, thanks, Tom. Both of us again. Okay, so how are we actually using this thing in practice? I'll get to this in a sec. Australia has put a large investment into OpenStack Cloud for research purposes, again, about 4 or 5 years ago. I think Finland's done the same thing. And there are a few other countries, quite a few other countries now around the world who are buying into this idea. And of course, Amazon is everywhere. We've actually used the Genomics Virtual Laboratory in a bunch of different places, in India and obviously a lot around Australia, but also in South America and South Africa and up in Ireland and the UK. We've even got a proposal to teach some courses in Fiji next year around microbial genomics, so I'm looking forward to that. not all of these are running on the local clouds. Sometimes we run them out of Australia. If we can, we try and run them on the local country clouds. One of our best users, I guess, is the Cloudman OpenStack cloud in the UK. This is a microbial genomics cloud in the UK across a bunch of different institutes, and they're using the GVL as a training and sort of practice resource across their cloud. And the really good news story there was it really took not very much effort to point Simon scripts at their cloud, build the required bits, and then add them as an entry to the launcher page, and now they can launch their own GVLs on their own cloud. But we'd just like to talk specifically about some quite, well, I consider at least quite sophisticated bioinformatics courses that we have taught using the GVL at different places. And the place where we have taught this particular workshop, the Microbial Genomics workshop, is in a few different places in Australia and just recently in Colombia. And I'll hand over to Simon, who is our Microbial Genomics expert.
Okay, so we've run this workshop quite a few times, probably 4 times now. Each time I've created many small instances of the microbial flavour of the Genomics Virtual Laboratory on the cloud and assigned one to each student or one to a pair of students. And I found that that works really, really well. Each student gets to play with their own machine using their own data, and there's no conflicts about having everybody on the same server. So this workshop goes for a day when I presented it in Sydney last time, and it starts at the very beginning where we teach people a little bit about what the cloud is, how to get access to it, and how to start a GVL, and then what to do with it once you've got it. So we talk about the different types of microbial data you can get, how to use Galaxy, how to do quality control, and then we actually get the students to do hands-on genome assemblies, variant calling, genome annotation, and then all the way up to comparative genomics using something like Mauve or ACT or Artemis or something like that. And all of this occurs all on the same machine. So all the students need is a web browser and an internet connection. And that's really, really powerful for us because, like I said before, who knows what the students are going to turn up with to actually start doing this course. But here's the thing that we think is really important, and this is that all the materials that all the materials we use are all available on the internet after the course for the students to continue to learn. And other topics are also available, and all of these tutorials all work on the GVL. And if you can leave the instances that you create for your students up for, say, a month after the course, that gives the students access to it again and again and again, and they can go and play with different tutorials or the same one again, or they can look at more advanced things, or they can even try out the command line. And it's all on the same machine that they've had access to for the training course. So all of these tools are all available at genome.edu.au under the Learn button. And so that'll list all the learning materials we have available for the GVL. Okay, so another really important reason for using the GVL in training is that the students can create their own GVLs in the cloud anywhere in the world. So they can use, where's that little green thing? They can use, say, Amazon in the West Coast or the East Coast of the US, Frankfurt, Sydney, the Nectar Cloud in Australia, the Cloudman Cloud in the UK. And all they need is access to that particular cloud. And this means that they can do more training by themselves, because all they need to do then is go and start their own GVL up, and they'll get the identical machine that they used during their training. That means that they can move seamlessly from training into practice without changing any of the infrastructure that they're used to. And they can use their GVL for their real work just as they did for their training. And we think that's the real strength of the GVL for training.
Okay. So we'll just finish up there. Thanks very much for your attention. I mean, clearly, there's a lot of stuff goes into making a platform like this, and lots of people involved. But it's probably taken us, I don't know, 3 or 4 years, I guess, to get to a level of maturity where we can start deploying the Genomics Virtual Laboratory happily on other clouds and be sure that it's going to work and it's going to be up and running. We hope that other people can, find some benefit in the effort that we put in, which has been quite considerable. And happy to take some questions now.
Can you hear us clapping?
We can hear you clapping, thank you.
Excellent. Yeah, thanks very much. That was really a brilliant presentation. It's really good stuff you have there. So for the questions now, actually what I would like to do is to ask those who have questions, if you can come up here, because it's nicer than that they can actually hear somebody else's voice as well and not just mine. So, and see you better than just in the distance. So, because I cannot really move this much around, I think. The microphone is attached to the computer here. So, does anybody have questions to Andrew and Simon? Yeah. Okay, so Nicolas Delhomme is coming, so he's from Sweden.
Well, I'm French originally.
As you can hear.
I was wondering, like, when you use AWS, how do you handle the costs and these kind of things?
So normally we just pay for it ourselves for a training course.
Sometimes Amazon will give out education grants and stuff, so you can use those. And that's what the Galaxy conference does every year. They get an education grant off AWS, and we can just start up web services for the whole conference, and it works pretty well.
But to be honest, most times we try to use public science clouds, and Australia's got a quite considerable one, and they seem to be sort of mushrooming up everywhere. So, yeah.
Okay, thanks.
Okay, any other questions? So Frederick Coppens from Belgium is the next person.
Hi. Follow up on the open or the science clouds that you use. What are the requirements that you need to be able to run this?
You mean the technical requirements of the cloud?
Yes,
yeah. Yeah. So normally you need volumes, and we have some sort of object store, which is where we copy over our large reference data resources. You can do it from the Australian cloud. You can use that as the sort of the source of all, but it just takes forever if you're not close to that. So what we try to do for each new cloud, I guess, is to put on obviously the root image and the reference data as close as possible, so they can be sort of copied over and assembled into the working GVL fairly quickly. And really, if it doesn't happen if you can't build one of these in sort of 5 to 10 minutes, then it's very hard for training. If people want to do that themselves, they sort of lose interest. They don't want to set it going and come back an hour later. So it needs to sort of happen relatively quickly, that you can assemble everything into a working image.
And the computes, I mean, the clouds that you're using, then, for example, here in Europe, that's an OpenStack that needs to be running. Or
yeah, so the one in the UK is an OpenStack cloud. We've used Amazon in Frankfurt as well, but the academic world sort of seems to be settling on OpenStack to a large degree. So yeah.
So they're working on an update to Cloudman, which is the infrastructure that controls how the GVL is assembled on the cloud, and they're currently writing a cloud agnostic version of that. So it'll be available for whatever cloud type you have.
so in essence, your cloud needs to be compatible with Cloudman.
Yes. Yeah. So I think they're working on a Google plugin for Cloudman at the moment.
I think the answer to your question is they're trying to identify the lowest common denominator of cloud services that is useful and write an API to it. So yeah.
Thanks.
Okay, next question. Victoria from the French Elixir now.
Hi.
Just two questions. One about Docker. If you use it already Docker for teaching or nothing at all?
So we can't really hear.
About Docker, if you're starting
better.
to use Docker or not at all yet, and what do you think about virtual machine? And the second one, it's about your federation of cloud.
Yeah.
Oh,
Okay.
sorry.
Okay, so with Docker, we've thought about using Docker in the past, and Galaxy now supports using Docker containers as some of its installable tools. And if it installs in Galaxy, then we can make it available on the command line as well. But we can also add in normal Docker support, and it's we've got the base version of Docker in there at the moment, and it works. But we just haven't had I haven't had any real use for it at the moment. But I'm sure there will be for things like specialized visualization software. A friend of mine is writing a Docker container for his client-server type visualization software, which I'll then try and incorporate into the GVL when we get a chance.
I can talk briefly about the Federation of Clouds. The Australian Research Cloud is a federation of clouds. It has 6 or 7 different nodes, and it has some cleverness at the back end where some things are automatically copied across the nodes. We've started looking at federations with some of the European OpenStack clouds as well. It often turns out that it's policy is the issue rather than anything technical, and how you distribute resources and allocate resources is a policy issue, and even within Australia that causes problems because universities provide the resources and they don't particularly want to give them out free to everybody who's not in that university, I guess. So I don't think it's any technical issue with connecting clouds together in clever ways. It really is around the policies. Yeah.
Okay. Are there more questions? Okay. If not, then we thank you very much again. And yeah, and well, I want to say that I got super envious when you mentioned that training course in Fiji. So if you need any assistant teachers there, just contact.
We'll be taking applications. Yeah.
Okay. Great. All right. Well, thanks very much again.
We'll hand over to Annette.
Yeah, and then we hand over to Annette. Yeah.